Happy to be here. My name is Kailash Narayanan, the president of Communication Solutions Group at Keysight Technologies. Communication Solutions Group represents about 70%. I want to thank Alex and the two Davids on team and Telco Forge for inviting me to be here. And it's a pleasure to be here. And many of the folks here are people that are experts at standard meetings, RF and protocol air interface experts. What I thought I'd do is just give you a perspective, an industry standpoint, engage with academic institutions, alliances like the ones represented here today, and also with the leading market players. And what are we thinking about 6G? See lots of, let's say, inputs, and you have to sort of detect the signal amidst the noise. So, pun intended. That's the metaphor there. What are the signals we're seeing as we craft the trajectory towards 6G? And at this point, we think that initial commercialization is 2030. As David pointed out, it could span 2030 to 2032. And we need to be practical about what makes sense. So I hope to provide you the perspective on that. Before I get started, I represent Keysight Technologies, as was mentioned before. We're a $5 billion company with 2024 revenues. I run the commercial communications and the aerospace and defense business, representing about 69% of the company. And what we do is we enable innovation workflows for our customers. And whenever there is a major trend, trend is probably not the right word, whenever there's a secular technology evolution, be it AI, be it in wireless, enable our customers to design, simulate, emulate, validate their prototypes, and enable deployments of these technologies for commercialization at scale. We have a large presence at Europe. Most of our innovation in wireless actually happens based out of teams in Europe. So that's something to note. So let me start off with a question. What do you think you'll be able to buy in the next few months, maybe within the next year, with $15,000 that you were not able to just a few months ago? Guesses? Software, you said? Yeah, okay. Okay. Okay, that's a good guess. So you guys all have to get loaded up on your coffee. So here's what's exciting about this. Recently, I saw a demo of a product that costs you about $15,000. And it's this little guy, okay? It's this little guy. I could speak to him or her. You can associate whatever personality you want with this device. It speaks in 22 different languages. I was able to ask it any question. In fact, I learned more about non-terrestrial networks interacting with this gentleman here than I did reading up on many papers. It was fascinating. And you could stop it anytime, switch topics. It had cellular connectivity. It had compute horsepower with this thing called GPUs. It had AI models built into it. It was just fascinating. You could train this gadget, this device, this person to do whatever you want. Simple things like perhaps moving objects. And over time, you might be able to train this person to walk your dog. Let's say you're taking a call, back-to-back calls for 3 hours straight. You need to have somebody play soccer with your kid. You could train this object to do that. You could train it to make coffee. You could train it to tutor you on any topic. Fascinating, isn't it? I don't think we could have imagined something like this even a few months ago. And it's a reality, or it will soon become a reality. And it's not costing you $100,000, $200,000. It's $15,000 now. Can you imagine? When time for 6G comes around, 2030 or 2032, could this be less than $4,000 cost of the higher end MacBooks or laptops? Absolutely, right? I mean, you can believe that, in 7 years, you'd be able to drive the cost of compute and connectivity for this device to be useful to everybody. So I think there's a lot of discussion around 5G. What's the killer app for 5G, 4G with social media and all of that? Wasn't the killer app for 5G? What is the killer app, device, etc.? It just can't be a smartphone. I think it could be this intelligent. And it's the convergence of connectivity and computing and software that's going to make 6G, AI, all of this a reality and enable commercialization at scale. It's not just about the smartphones. So that's some food for thought, and I think we're seeing more of these possibilities as we look ahead. So that's sort of the theme here for my talk, and I'll start with a overview of what 6G represents. Many of this is probably not new to you. Clearly, there is complexity, challenges that come from a technical perspective, and potentially also from a geopolitical perspective relative to the previous generations that we've seen. But there is 10x improvement in bandwidth, there's 5x improvement in latency goals that the industry and ecosystem is seeking, 10x improvement in quality of service, and 1,000x improvement in performance. And I think of all of those four, I don't know if we need a 10x bandwidth. Probably, right? All of us start walking around with those intelligent companions. Do you need more connectivity and compute? I think instinctively, intuitively, you feel like, yeah, that makes sense. We probably need that. How much of that can be done with something like Wi-Fi versus cellular? I think that's a question that we need to answer. Compute and quality of service is going to have an order or 2 orders of magnitude improvement as we look ahead into 6G. And I'm particularly excited about the conversation the industry is having about 6G, focused on businesses, business models, the monetization of use cases, as much as it is about technology. It's not just about data rates, it's about enabling this convergence of computing activity in the form of new services and new devices. So I can't remember during the early stages of 5G that this occurred. I think we kind of took it for granted, right? We said it's going to be high data rates, it's going to be low latency applications, it's going to be autonomous driving and remote surgery and massive millions of IoT devices and so forth. We just took it for granted. The business case was there. We largely focused on the technical aspects, F1, F2, NSA, SA, and so on and so forth. Now, I think there's more scrutiny, rightfully so, and it's going on in parallel while we're addressing the technical side of things. we're also moving dialogue forward on business models. So that's exciting because I know when we focus on something as an industry, as an ecosystem, we will sit. Timeline-wise, everything seems like it's on track, right? You look at 2015, I think that was the first 3GPP meeting. We had the first 3GPP meeting in March in Korea, and we're looking at 4 to 5 years from the first 3GPP meeting to commercial launch. It's our perspective. We're still, you guys, many of you guys will help influence and decide this, but 2029, March, April is when the standard gets finalized, release 21, and we think it's probably another year, 18 months from that point for initial commercialization. And then scale commercialization potentially occurs in 2032. So timeline-wise, I think we're on track. And like I said, not that 5G was not business-centric, but it was the emphasis early on. We planted business models, business use cases, and applications will follow. But in 6G, there was a lot more focus on the technology as well as the business aspects, the monetization aspects, is sustainability, security, the area that we need to focus on. Lots of more diverse set of topics and questions that are being asked. This is being asked by the academic as well as the research communities, but it's also being probed on and researched by CTO offices in various companies. So with that as a backdrop, let me kind of pull up 3 key things. My perspective, at least, based on what I have seen in the industry so far, there are 3 themes that pop up, and I'd say at this juncture, this could be kind of the signal, right? So you have AI-enabled devices and services. I think 6G is going to, if you haven't kept track with AI, I would highly encourage you to do so. We don't want to be living under a rock, and it would be super critical to understand the implication of AI on 6G and vice versa. So the 6G is not happening without some or significant use of AI. 3D networks. I think non-terrestrial networks are going to become ubiquitous, and they are going to coexist with terrestrial networks. A lot of innovation in this area, and obviously there are a couple major players in the world now pushing for this, but there will be a lot more local as well as global operators. And when I say operators, I just don't mean old network operators, but new operators that provide different kinds of new kinds of services. So I think we're seeing a clear signal here in terms of the research that's going on, in terms of practical implementation and investments. And finally, monetization. See what that means and how the system is progressing through monetization and business models. So I'll start with AI. I think it's only appropriate to start with AI, even though this is a wireless forum. You see the push of AI and new players coming into the market to integrate AI into wireless networks. Today, most of the work that's going on in AI is obviously the data centers. The data centers of hyperscalers and other companies. There's massive investment in this. There's infrastructure expansion, data center infrastructure expansion. You have these GPU designs, AI server designs. They all get kitted up in a rack. And that's a rack that could have 64, 128 GPUs. And from there, you replicate these racks into AI clusters, and many of these clusters, sometimes containing hundreds of thousands of GPUs, form a data center. And these are the data centers that are training some of these models, right? And today you have, but this is not the only game in town. Once the data centers always train these large language models. They will provide low latency services to help users figure out what they need to do. The device that I talked about earlier was using one of those models to interact in English and a couple of other languages, but it could speak languages. Now, you can imagine when finally AI gets to end user devices, AI-enabled PCs and smartphones and robots, etc. That AI computation needs to move closer to the edge of the network than also occur on devices. So AI computation is going to happen at scale on devices. It could be a smartphone, that could be a PC, that could be a robot. And it will exchange information, data, and workloads between itself and the edge of the network, and finally going to data centers when there's a need. This poses a lot of challenges, right? So GPUs, what GPUs are today, you're going to have a lot of custom purpose AI chips, DSP accelerators, and so forth that will run at the edge of the network and devices. Today, what took 70 billion tokens and lots of GPUs to train the first ChatGPT model, it can actually be done with less than 10 billion parameters on focused chips that can run on smartphones or on PCs. So you'll see more of this augmentation with new silicon capabilities. Second, these AI models, what are these AI models? I mean, they are essentially estimates, data-driven estimates. So you're going from predictable and systematic algorithms that you use to implement functionality to probabilistic models. Right? So if it's a base station, you're going to implement some of the functions of the base station using AI models versus predictable algorithms. And that's just one example. So you'll see more domain-specific models, and these domain-specific models have to be assessed for integrity, fidelity, security, performance, and so forth. So that's a change that you'll see, going from large language models to smaller domain-specific models. I don't know if many of you realize when you train these large language models, it actually ends up destabilizing the grid, because the electric power grid is set up for an industrial society, which means that after 6 p.m., it's mostly residential power use, and the grid is not expecting a huge pull. But with networks and everything becoming software-centric, and with data center infrastructure and AI expanding, what's happening is you go into this continuous integration, continuous development loop, and it's software that's getting trained, and it's 24/7, and these data centers actually pick up and start training models, and that's a huge suck out of power from the grid, and the grid tends to get destabilized, and the grid utility company CEOs call the hyperscaler CEOs, and this is a big concern. So computing obviously is getting energy intensive, and there's plenty of opportunity for us to innovate in the wireless domain, in the convergence of connectivity and computing from an energy intensity and sustainability perspective. And we're going to see today all of the stacks, the AI stacks, the technology stacks are proprietary, and you're going to see more of this move into a quasi-standardized mechanism. You will see things like UA Link and Ultra Ethernet Consortium. These are parallel bodies, and I'm sure at some point or at least have shared topics to discuss to bring about standardization or semi-standardization across the wireless and wireline stacks. So that's kind of the bigger backdrop on what's going on with AI, and you can see how it's transforming radio access networks. We're already moving to new techniques. I mentioned about functions, network functions getting implemented as AI trained models. We have new topics now in 6G, like integrated communication sensing, allocating a portion of the communication bandwidth towards sensing. And without that, how are you going to enable things like robots to turn around corners and see more precisely and assess the shape of objects and so forth? Look at the other contrast, right? If you look at 5G, it's mostly been about data rates, and it's mostly focused on wireless connectivity. And tomorrow's networks are going to be, there's some virtualization and software it's there, but it's still a hardware-centric network. We've progressed significantly from 5G towards software centricity, but in the future, 100% software-centric, 100% cloud-native, 100% AI native. That's where we're heading to. And you have to think about the network itself as a sensor. The network itself is a robot, right? Somebody once told me, what's kind of the definition of a robot? A robot is something that senses what's going on around it. Based on that, it computes, much like a human being, and then responds to its environment. Perhaps what we talked about in 5G, massive IoT, these massive IoT devices are all over. The next 5 years, you're going to have more of that, lots of transducers. The network itself becomes a sensor. It's able to detect, whether it's to drive utilization up, whether it's energy sustainability, whether it's to dynamically adjust workloads and traffic and so forth. The network itself becomes a sensor, models, and there's compute that now is able to process all of that data. And that's the key thing. We still were driven by centralized computing algorithms and wasn't as agile and as dynamic. And this is the big change. AI and computing, radio access networks, the network is truly able to act as a robot, act as a sensor, and perform better. So if I have to describe what a 6G RAN network might look like, not to have a play on words, but I'm thinking of 4 Ds, right? 4 Ds. It's dynamic, it's very agile, based on this network as a sensor concept and based on computing and connectivity integrated into it. It's completely disaggregated, hardware, software model perspective. It's distributed and decentralized, truly. So across the devices, edge network, part of the RAN, all the way into the data centers. It's totally decentralized with significant autonomous decision-making capabilities, and it's deeply intelligent. So those are kind of the 4 Ds. It's dynamic, it's decentralized, it's disaggregated, it's deeply intelligent. And this enables a lot of things. It allows you to have real-time adaptation, speaking to the agility of the network. It speaks to predictive optimization. I mean, all of those things that were ideals of 5G, let's say. Now you can see a line of sight to making all of that happen in 6G. There's predictive optimization and there's autonomous decision making. So this is the network. This is where we're headed. Things like AI, off RAN, by RAN, for RAN is all integrated and part of this general theme of having the network as a robot with enough compute capability, enough disaggregated AI-driven compute capability that makes this possible. So that's on AI, right? So we have devices, we have networks that are going to be influenced, and services that are going to be influenced by AI. I think that's that's a reality that's going to be here to stay. You have many, many new players, including big GPU companies that you know of, that are now involved with RAM. We're not involved with something like that, even during the 5G cycle. So new players are coming in, there's new investment, it's inevitable, and we see potential in devices and services. So AI is real, and it's going to drive and shape wireless innovation. The next one is NTN, satellite connectivity. You think about what's going on today with 4G, it's largely a direct to cell, right? So we do have a LTE direct to cell connectivity, let's say partially, and that's supported. And I think with 5G, especially with the next couple of releases of the standard, it's becoming more transparent. It's a transparent architecture with more seamless handover between ground towers and satellites and so forth. But with 6G, I think we're going to a very ubiquitous, systematic, scale, regenerative architecture, right? With dealing with multi-orbit satellite systems and providing seamless connectivity in conjunction with terrestrial networks. So that's the key piece here. And you're seeing this, we're seeing this from an industry perspective. It's going to help drive new services and new subscriptions, no matter where you are in the world. I think it's beneficial to mobile network operators who might become an operator, a direct satellite operator, or they may lease satellite connectivity services from other operators. So bringing in newer players and newer ways to monetize. So I think this is a real, and the coexistence of terrestrial and non-terrestrial networks will be a big part of the standard, and we'll have to figure out complexities associated with it, especially thinking about geopolitical considerations as well. So you're going to have some local operators, you might have some global operators. They all need to coexist in this new paradigm. So think about this, right? I mean, this is a representation of what a 3D network might look like. You've got work going on, perspective on NR and on NR-NTN. Again, whatever is happening with satellite connectivity today is proprietary, maybe based on NB-NTN, and there is direct to cell connectivity from an LTE perspective. But you have new types of devices, you have flying nodes, drones, you have other high altitude platform systems, not to mention huge constellation of satellites. And these LEO satellites may be at multiple orbits, right? So you have a multi-layered architecture, multi-orbit system that you have to coordinate. You have all of these satellites moving at 27,000 kilometers per hour or something like that. So you have a moving network connected to relatively stationary devices that needs to coexist with moving devices and the stationary network on the terrestrial side, driving a huge set of complexities. And think about many operators, local and global operators, wanting to do this, not just a couple of big players that are involved in this today. It's going to drive a lot of complexity, but it also provides monetization opportunities, business opportunities, as it expands coverage in urban areas, in oceanic sort of regions, as well as remote. So that's something that's a clear signal. So then I'll move on to kind of the third vector, right, which is 6G monetization. And it's being discussed. I don't know if it's become a work item on the standards or not, but if it's not, it's something that is going to get discussed. In the Korea meeting in March, of 230 plus papers and tracks that were discussed, 1,500 of those, there were 1,500 references to AI, and there were over 500 references to non-terrestrial networks. So you can kind of see where the industry is, right? And a lot of side chatter about business models and monetization. But I think people are seeing line of sight to how there could be new devices, new monetization opportunities, new service models, right? Getting these hyper-personalized devices. Everybody, autonomous driving was back in 2015, 2016, when we were discussing and having these types of discussions, autonomous driving was, as we said it, well, it's real now, right? It's being done with a proprietary stack and just by a couple of players, but you can go to San Francisco or Phoenix, get the Waymo rides today, $20, right? $20 and might be more expensive. Sure they're being subsidized today, but you can, it's not scary at all. I don't know how many of you have been to San Francisco, you go up and down those hills, and it's a Waymo that takes you. And entering into the car, you feel a little, you feel like, man, I'm trying to do something very different, but getting out of the car after an hour, this feels normal. So autonomous driving has become a reality already. So you have this robot thing that I said where software merged to offer new levels of personalization, being a very intelligent companion to you and your family and friends. I think that's real. Industrial automation is real. I mean, it's probably a way to say what private networks should have been in 5G. Private networks didn't quite take off in 5G because we had the connectivity, but the connectivity wasn't differentiated enough from LTE and some of the Wi-Fi standards, and the compute was not there. The robotics and the innovation in robotics was not there. Now you have AI models, robots, who have very low latent connectivity and compute that will make industrial automation at the small scale and at the large scale reality. So these are new ways of monetization. We talked about satellite connectivity area as well. So anything that you see in there, and outside of RAN becoming more efficient, better utilization, better sustainability, better energy consumption models, and so forth, all of this I think we can see is going to be a reality. And this is augmenting the traditional mobile user subscriptions. So we're just not relying on mobile subscriptions to drive 6G, leverage 6G. There are many more use cases, and I think we can see line of sight to those use cases because of the progress that has been made in AI and compute. So with that, let me close with a couple of slides. We are furthering progress on 6G by collaborating with all of the global alliances. And what's exciting is we have started here in Europe with actually the Genesis flagship program. We're partnering with 6G SNS. And not only that, we're seeing more 6G work going on in different geographies. And our value is really to partner with these alliances very early in the cycle to drive 6G forward. And we're focused on the traditional things. We're pushing for higher bandwidth, different frequency bands, all the way down to 400 megahertz to a terahertz. So we're doing all of those things, but in addition, it's the focus on AI and ML. How can we enable AI and ML networks and devices and services? That's the key thing focused on. And this means that most of the networks, whether it's wireless or wireline or satellite, simulated and emulated software environment to understand the physics behind that prior to deployment. So there's intense focus on digital twins, and we've showcased many of those technologies at the most recent Mobile World Congress, and you'll see some of that outside here today as well. And we're supporting and furthering non-terrestrial networks as well as open RAN networks. I mean, this is where the disaggregation, decentralization, and deeply intelligent networks come into place, and the coexistence of terrestrial and non-terrestrial networks. So in addition to the fundamental spectrum and waveforms and modulation techniques, so on and so forth, we're going to be covering FR1, FR2, FR3, all the way up to sub-terahertz bands. But it's really these other things that are going to enable 6G, and we support that. So in summary, I'd say keep these four themes in mind. AI driving 6G, they're kind of there is a symbiotic relationship. I think AI is going to 6G, 6G is going to influence AI. It's going to be new technology. I think Isaac FR3 seems like FR3 is a very practical way of generating more bandwidth without getting into a lot of practical difficulties that prevented FR2 from being deployed at scale. Sub-terahertz research will happen, but obviously physics prevents it from being deployed beyond line of sight sort of communications and applications. I think there will be some, but it's going to be largely FR3 based. Non-terrestrial networks, the coexistence, 3D networks, terrestrial plus non-terrestrial, big deal. And let's kind of continue to think about monetization. Let's continue to think about newer players, how they might benefit from 6G, and how these new services and devices will drive the commercialization of 6G. And I'll just say that if we remember that 6G is really about convergence computing activity, I think we build the right kind of 6G devices. Services are going to be born out of this concept. I think if we just think about a new era interface, we make some progress, but not as much progress as we think about it as. So with that, I'll turn the day back to all of you. Really appreciate the opportunity. Yorcom and Telco Forge for inviting me to talk to you this morning, and we'll see you all in some other settings soon. Thank you.